How are you, my dear grade 11 students? Today we will talk about grade B, our pre-calculus syllabus. In the previous lesson we talked about solving equations in one variable in lesson 2.7, and now in lesson 2.8 we'll talk about solving inequalities in one variable. So, what you will learn about polynomial inequalities, rational inequalities, other inequalities, applications, and why for designing containers, as well as other types of applications often require solving an inequality. Polynomial inequalities is containing f of x greater than 0, greater than or equal to 0, less than 0, less than or equal to 0, or equal to 0. Or sometimes where the function is undefined, it means f of x not equal 0. So here from this graph, it's clear that the values where f of x equals 0 lies on x-axis, it represented by the zeros of the function or x-intercepts. And the function is positive, it means f of x greater than 0, it means all the intervals of the function lie above x-axis, and f of x is negative when f of x less than 0, it means all the intervals of the function lie below x-axis. Let's see example 1, finding whether a polynomial is 0, positive or negative. Let f of x equals x plus 3 into x squared plus 1 into x minus 4 all square, and we need to determine the real values of x where f of x equals 0 or positive or negative. So the first part we will determine where f of x equals 0, it means by finding zeros of the function. What does zeros of the function represent? Zeros of the function represent all the values when f of x equals 0. Okay, now we will see the solution. To find that, we will put f of x equals 0. It means x plus 3 into x squared plus 1 into x minus 4 to the power of 2 equals 0. So we have to determine that the odd multiplicity and even multiplicity, or multiplicity 1 and multiplicity 2, when we have a part of the graph or a part that containing the power of 2, it means it's multiplicity 4. Multiplicity 2 or even multiplicity, it means in this part the function goes, all the parts touches x-axis and all the parts lies in one direction. Both are positive or both are negative together. So here, if f of x equals 0, so x plus 3 into x plus 1, or x squared plus 1, and x minus 4 all squared equals 0. So we have to solve this equation to determine the values or the zeros of the function. So in this case here, from this one, we can say that x plus 3 equals 0. It means x is equal to negative 3. And from this part, x squared plus 1 equals 0, and this one has no real 0, has no real zeros, because here you can find that x squared equal negative 1, and you can't find a square root of negative 1. This is imaginary part, not real. And here x minus 4 all square is 0, so you have to find the solution by finding a square root. It will be x minus 4 equals 0, so x is equal to 4. So in this case, what are the real zeros of the function? X minus 3 and x equals 4. This is how can find the real zeros of f of x. And now we can see the graph of this function. Okay, this graph, as we see here, had the points of intersection at -3 and 4 that are the real zeros, and here we have a part from the graph lies above. So here you can see that here in this part, f of x is positive, it means it's greater than 0, and here below f of x less than 0. It's okay? A positive. So where the function f of x is positive, it means f of x greater than 0. So x plus 3 into x squared plus 1 into x minus 4 all to the power of 2 greater than 0. And in part C, we need to determine where the function is negative. It means f of x less than 0. That means that x plus 3 into x squared plus 1 into x minus 4 all to the power of 2 less than 0. Now we will use a sign chart to determine the intervals where the function is positive or negative. And the sign chart includes the real zeros of the functions that we found in part A. The real zeros are negative 3 and 4. These are the values of x. We put the values of x up here and f of x down. And here we know that at negative 3 and 4, f of x equals 0. And what about here? We have to check the values before negative 3 here to check this interval. All the values, we choose negative 4 as an example of a value less than negative 3. And substitute in our function by negative 4. When we substitute, we can find, for example, f of negative 4, and only I determine the sign. So it will be negative 4 minus negative 4 plus 3, okay, into negative 4 squared plus 1 into negative 4 minus 4 all to the power of 2. Here we substituted by that. Always we determine that here in this part, the next two brackets, x squared plus 1 and x minus 4 all squared, always positive. Okay, and here we check the change here for the first bracket. So here the first bracket in this case is negative. So we have negative multiply positive multiply positive. So the value here is negative. And the next, we substitute by 0 in the interval as an example of a value between negative 3 and 4. You can choose any value here. You can choose 1 or 2 or any other value, or negative 1, it's okay. So by substituting here, all the signs are positive inside parentheses. Therefore, here the value of the function in this case is positive. And check for any value greater than 4, for example 5. So here we can determine that it is positive for all. So here we can say that the function is negative when it's below 0, when it's below less than, when x less than negative 3. So this part of the function lies below x-axis. and the function is positive into two intervals. So it's from -3 to 4 and from 4 to infinity. So f of x is positive, means greater than 0 on interval from, no, here it's not positive here, from negative infinity to -3, it's not positive, it's less than 0. So here it's what here? It's negative. Okay? And here it's positive in another. So here the intervals here changed, not the same. Let's erase here. So here it's positive. Let's correct this interval from -3 to 4. Union from 4 to infinity. And it's negative from negative infinity to -3. That's right. Here negative, positive, and here positive. It's okay? Yeah. Odd and even multiplicity. From the previous example, we can see that at -3, the function intersect x-axis and passing from a positive part or a positive value above x-axis to a negative direction below x-axis. So we call it at -3, there is odd multiplicity. It means the sign changes of the function. The sign of the function changes from positive to negative or from negative to positive. Okay? And at 4, we can call it even multiplicity. In this case, no sign change. Both here below 4, it is still here in the positive part. In this part, it goes here and touches 4 and go again to the positive part. Okay? So, at the left and the right parts, we can call it negative due in the behavior, and here positive due in the behavior. It is the in the behavior of the function on the left side and the right side, and between -4 and +4, positive due to multiplicity of zeros. Okay, so what are the zeros? -3 and 4. The sign chart and the graph of f of x equal x plus 3, x squared plus 1, x minus 4 all squared. Example 2. Solving a polynomial inequality analytically. Solve f of x equal 2x cubed minus 7x squared minus 10x plus 24 greater than 0 analytically. Solution. Let f of x equal 2x cubed minus 7x squared minus 10x plus 24. use the rational zeros theorem, where P over Q is 24 over 2, where 2 is the leading coefficient and 24 is the absolute value. So the rational zeros theorem is talking about how can we divide the absolute value over the leading coefficient and factorize each one. So we will use the factors of 24 and the factors of 2. So the factors of them are negative and positive 1, negative and positive 2, negative and positive 3, negative and positive 4, negative and positive 6, negative and positive 8, negative and positive 12, and negative and positive 24. It's for 24. And for 2, we have negative and positive 1, negative and positive 2. So we will divide all the factors of 24 dividing by the factors of 2. We can see that all the rational zeros are negative, positive 1, negative and positive 2, negative and positive 3, negative and positive 4, negative and positive 6, negative and positive 8, negative and positive 12, negative and positive 24. It's by dividing all these factors by 1. Okay? And when we divide by 2, all are repeated except we have 1 divided 2 is half, so we have negative and positive half, and 3 divided 2 is 3 over 2, so we have negative and positive 3 over 2. So here we will use statistic division we will check dividing by at x equal 4. So a table of graph of f can suggest which of these candidates to try. So graphically we can determine from the graph, if we use graph of the function, in this case x equal 4 is a rational zero of f, and the following statistic division shows. So we will divide here 2, negative 7, negative 10, and 24 are the coefficients of the polynomial, and we will divide it by 4. So we will start by putting 2 down, and then multiply 2 by 4 is 8, then add negative 7 plus 8 is 1, then 1 multiply 4 is 4, and negative 10 plus 4 is negative 6, and negative 6 multiply 4 is negative 24, so 4 plus negative 24 is 0. It means here there is no remainder of the function. So for our function f of x equal 2x cubed minus 7x squared minus 10x plus 24, it equals x minus 4, it's one of the factors, multiplied by 2x squared plus x minus 6, and this is the result we found from statistic division. So we will factor 2x squared plus x minus 6 into 2x minus 3 into x plus 2. 2x squared is 2x multiplied x, and 6 is 3 multiplied 2, and the sign is positive for the highest value, that is 2x multiplied 2 is 4x, and negative 3 multiplied x, negative 3x. So here, or you can use mod 5-3 to determine the zeros here. Okay? So the zeros of the function means f of x equals 0, or x, as we said, it's x-intercepts of the graph at x equal 4 and 3 over 2 and negative 2. And we can see that from the graph. You can check by using Desmos and graph your function, and this is the graph. We can find that here the points of intersection here at negative 2 and 0, and 1.5 and 0, it means 1.5 is equal to 3 over 2, and the last one is 4 and 0. And we can see here the function is negative in two different intervals here, from negative infinity to what? From the graph here we can determine that from negative infinity to negative 2, and here it's a negative also from 1.5 to 4. So we can use union between these two intervals. And the function here is positive in the interval between negative 2 and 1.5. And also from 4 to positive infinity according to the end behavior. And here we can use union. Therefore here we can say here in this part f of x is positive, it means greater than 0, and below here f of x is negative, it means it's less than 0. And as we said here on x-axis, f of x equals 0. So algebraically we can see that from what? Sign chart. On the sign chart we will use the zeros we found for the function negative 2, 3 over 2, and 4. And we know that at these values f of x equals 0, and it can check for values for x below and between each values and after, before and after each value, to check the sign of f of x. If the sign of f of x after finishing the calculation is positive, it means, okay, it's positive, it means it's above x-axis, therefore this interval represents a positive part, and when it's negative, it's below x-axis. So we will determine here by substitution by negative 3 in the function. We can see the function is negative in all. So by substituting in all the parentheses after factoring, negative times negative times negative, it means here below negative 2 or less than negative 2, the function is negative. And between negative 2 and 3 over 2, the function is positive. And between 3 over 2 and 4, the function is negative. And greater than 4, the function is positive. So f of x greater than 0, positive on intervals. So here these two intervals for positive, from negative 2 and 3 over 2, union 4 and infinity. This is the first part. And f of x here, the question asked about positive, not negative. But we can talk about negative when we are asked about the other two intervals. Let's talk about example 3. Solving a polynomial inequality graphically. How can we represent it using a graph? We can use Desmos, and it's easy to do that. So solving a polynomial inequality graphically, solve the inequality x cubed minus 6x squared less than or equal to 2 minus 8x graphically. So how can we solve? Let's see the solution. First, we rewrite the inequality x cubed minus 6x squared less than or equal to 2 minus 8x as x cubed minus 6x squared plus 8x minus 2 less than or equal 0 by moving negative 8 and 2 to the left hand side. So then we graph the function f of x equal x cubed minus 6x squared plus 8x minus 2. And find the real zeros of f graphically as shown in the following graph. So this is a graph that we drew using Desmos. We can see that the points of intersection here, okay, 0.32487, so it's approximately 0.32 and approximately 1.46 and approximately 4.21. So here he wants to find values where f of x greater than 0 or less than 0. When we simplify it, we need to find where it's less than or equal to 0. So equal zeros are for the points of intersection, okay? And less than zeros for the intervals below x-axis. So here we have the interval from negative infinity to 0.32, and another interval below here, it's from 1.46 and 4.21. So we use union for these two intervals. So and this is the solution of our function. The three real zeros of this function, as we said from the graph, approximately 0.32, 1.46, and 4.21. And the solution of the given function, x cubed minus 6x squared less than or equal to 2 minus 8x is negative 8 and 0.32 union closed interval 1.46 and 4.21. Where we use closed interval here, because closed intervals here represent for the part where it's equal 0. If it's not equal 0 here, we will use open interval only, okay? But because it's a closed interval, it's less than or equal to containing equal, we use the closed interval. It's okay? Now we will have some questions for exercise, and you have to solve it at the end of the session, and I wait your solution to send them to me here, please. So in the first one, we need to determine the x value that cause the polynomial function to be 0, positive, or negative. Okay, positive means f of x greater than 0, negative f of x less than 0, 0, it means the zeros of the functions. And here you can support your answers with graph. So these are the questions, and it's easy, they are all polynomial functions. And another question, complete the factoring if needed and solve the polynomial inequality using a sign chart and support it graphically. So here you have to use algebraic solution using a sign chart. So these are questions from 7 to 12. Another part of questions, solve the polynomial inequalities graphically. So here it's allowed for you to use Desmos, so you will, it gives you more practice for using Desmos, okay, that you use in SAT exams, okay? So these are all the questions required. If you solve these questions, it will be easy for you, okay, to do any question like that. Thank you and goodbye. Inshallah, I'll meet you in another lesson later on. Thank you, goodbye.